present?
Sure. There is no USB-C.
Okay, I can.
Okay.
Okay. Work. Guess we'll be. Can I start? Hello, everyone. Welcome to this presentation. My name is Piotr Kwidzinski. I'm representing AMD, and with me.
Hi, I'm Thordur. I'm from Google. Security engineer, not architect, but no big difference.
Yeah, so today we're gonna present update on the Caliptra project. We'll start with some recap what Caliptra is, and then we'll go over some recent news in the Caliptra space and Chips Alliance, where you can actually find all the repositories for Caliptra, and we give you update on the latest architecture changes, mainly around dice protection environment. And then we should have some time for Q&A as well. All right. So Caliptra, for those who never heard about it before, it's a specification for Silicon Root of Trust internal block. Meaning it's not a discrete component, it's IP that can be integrated into existing products by any vendor. And it was published as a OCP specification during the last Global Summit in October last year. This is a project that we've been working on for a couple years now. Multi-party collaboration started between AMD, Google, Microsoft, and later NVIDIA joined as well. And I left 3 dots because we are definitely looking for anyone else interested in collaborating and joining us in bringing this into market. It's a fully open source specification as well as implementation. So all the components of the Caliptra from hardware RTL up to the firmware are fully open source and available in the public repositories at this point. It's also the first security project specification that is actually building a technology block, including all the components, hardware and firmware. And we did presentation with quite a bit of details about the Caliptra architecture and all the goals in the Global Summit. The video from that presentation should be available on the OCP site, so encourage everyone to go and check it out. Okay, so recent news and updates. So since our presentation in Global Summit last year, we created a number of public repositories through Chips Alliance that are currently available for everyone that signs the CLA. Actually, you can go and access those repositories, but if you want to contribute or provide any comments, you need to sign a CLA. We also have a weekly Caliptra work group that is open for public. We're running it on every Friday at 9 a.m. Pacific time. You can sign up through the Chips Alliance work group registration. The link is on the slide. I encourage everyone. It's free to attend, and you can learn all the current updates on what's happening, and also we encourage people to come in, ask questions, and discuss any topics related to Caliptra. From the repositories itself, we just recently released what we classify as a point A level of RTL. It's available right now under Caliptra-RTL GitHub. The 0.8 version is really ready for initial integration into SOC. It's not, fully. It's pretty much close to the 100% functionality, but it's still going through the proper verification and validation. So it's basically at the point where we are freezing the features for the hardware, and vendors are starting to integrate those into their subsystems. And then we have separate repositories for the firmware. There is one for ROM and first mutable code, and then there is one for runtime firmware, which is mainly the DPE services that we're gonna talk about. Okay, so we also have a technical advisory board that is maintaining the changes into all the Caliptra repositories. Any new updates, any changes to either hardware or software have to go through a review process and has to be approved by the TAC members. Currently, maintainers are from the 4 companies that initiated the project, and we have different maintainers for each of the repository, and you can find all the details under this link with all the names from each company maintaining the contributions for each of the repo. So high-level diagram, again, as I said, we give pretty detailed overview of Caliptra in the Global Summit, so I just want to quickly rehash very high level the key components of Caliptra. So it's built around the RISC-V microcontroller, and it has a crypto subsystem integrated. And then it has an additional set of resources or interfaces that has to be provided by the vendor that integrates this into the SoC. So the purple blocks are basically the blocks that has to be provided by the vendor, by the integrator to make this whole IP workable. Okay, so I'll switch to Thordur to go over DP.
Yes, so kind of the architecture of working with Caliptra as an IROD is this TCG dice protection environment, DPE, which can be thought of as kind of the API towards it. A little bit about dice to start with. Dice is basically a specification that you can quickly kind of describe as this device unique secret. If you, from the previous slide, that would be the puff and even some fuse entropy. And then a ratcheting mechanism for basically mixing your measurements into that and then generating CDIs, compound device identifiers. The DPI is responsible for kind of holding that and protecting it, and then providing a API layer to the rest of the SoC. And each layer kind of in your boot chain gets its own context that it can then use to request services from the DPE service, which is usually sign, here, which is, derived child for the next thing, sign something, for example, at an attestation, certify a key, or destroy the context. like you see, the DPE is kind of the Caliptra IROT, the ROM from it, and the FMC, and then the kind of the application firmware that runs the DPE environment itself. As it is implemented today, it's a direct interface. There's this raw struct ABI, no CBOR, pretty simple. And it's available today if you go to the GitHub repository. The DPE repo has both the implementation and a simulator. And it becomes kind of obvious that this being an API, that the simulator is just a Unix socket that you can interact with, load your context and play with the signatures and stuff like that. Simulator is obviously not intended for any production usage. It's basically for testing. There's also a verifier there that you can use to kind of run the DPE code itself and the RTL of the Caliptra the Caliptra itself on top of it. So what's next here? Yeah. So to kind of make it useful in the form of like the whole SPDM world for attestations and things like that, you end up with these singular X509 certificate. The reason for that, rather than having a chain of certificates, is it becomes pretty difficult to maintain that chain in a world where you would like to implement updatable measurements or even support partial resets of the SOC or even some hitless upgrades. The way that DPE kind of helps with that is for each of the blue things you see in the X509 certificate there, you can, as a SOC integrator or architect, define tags for each of the blocks that Caliptra and DPE can then manage. And those tags can be used to query individual measurements for your kind of your tree of the SOC. This can, allow you to, if you don't want to, like if you have a very complex SOC and then a host application CPU, and you just want to reset that one, not the rest of the SOC, you can implement it via the tagging to just destroy all of the contexts above and then reload them. And if you're running that with certificate chains, it becomes difficult to kind of route back into the Caliptra root of the measurements, which is why it's just one certificate.
Yeah, and I think just to add, right, it's a single certificate and it's always generated fresh based on the current measurement, right? So
Yeah.
from last use, if you do a hitless update of any component that was included, you will get fresh certificate on the next use.
Mm-hmm. I mean, it comes with the fact that you need to, at some point, ingest a root CA that signs it, kind of standard. Yeah, that was kind of it for me.
Yep. Yeah, and just to add, the DPE as the primary interface for Caliptra, and it's available for the internal mailbox. And we are also looking at some differentiation between the trust level for the DPE users. Didn't capture on the slide. This is still under discussions, but we are leaning towards having like a two-domain, one within the SOC for internal use, which we consider trusted, and then one for the application processor running host application, which is less trusted, and we will provide a way to differentiate those certificates between the two domains. All right. I think that's it on the technical side. So call to action, as I mentioned, encourage everyone to attend our weekly Caliptra work group, where you can ask questions, provide feedback, and also contribute directly to the repositories, either on the RTL hardware side or the firmware. As mentioned, there is a need for CLA to be signed with Chips Alliance to allow the participation. And in terms of timelines, we published point 8 fairly recently. It's available. The initial boot ROM, FMC, and DPE firmware is also available right now. We also have emulator, as Thordur mentioned, so you can actually take the firmware and run it on the emulation with the actual Caliptra RTL if you're not ready to integrate into your own environment. And yeah, we're targeting fall this year to be 1.0 ready for integration and productization in the product. So again, encourage everyone to take a look. The Caliptra IO is a redirection link to the GitHub repositories, and I would encourage to start there. And yeah, I think that's it. If we can take some questions, comments. Mhm. Yeah, so there will be multiple level of verification, right? Formal verification. So we are working with third-party contractors to help with the verification of the RTL itself. And for each formal release, like following point 9 and 1.0, we will have the full formal verifications focus on the crypto block and boot ROM mainly, right? Which is a basis for your root of trust. But then the whole firmware stack, I think, Tudor, you guys have an additional presentation later today on the formal verification of the firmware stack. I don't know if you want to.
I mean, it's not going to be a formal verification. It's going to be a security review.
Security.
I mean, it's software. I mean, we shouldn't need any security reviews. It's written in Rust, so no. But no, there's going to be third-party audits. We are also standing up teams inside our own org to do similar security audits that we do for our own products, and try to do that for every release of Caliptra. And the real hope is to have the scope documentation for those reviews completely open, the artifacts from the reviews completely open, and then also contract with third parties to add to the eyeballs that have gone over the code.
Yeah, and we are also, it's not committed at this point, but we are also looking at doing FIPS certification. Well, we can't do certification until it's an actual product, but we're gonna do preparation for FIPS certification. So we'll work with the FIPS contractors and labs to provide the maximum set of FIPS documentation that vendor can use for the formal FIPS certification. Yeah, I don't think anything is published yet. There are collaterals that we are using for testing. So aside from the RTL itself, you get all the testing environment as well. But the formal testing results are not published yet. They're currently literally in the process of doing it. So. Yeah.
So that depends on the component you're updating, right? At the like in the limit, if you're updating whatever the host OS is running on, then it's going to get notified. If it's another component of the system itself, it might not even know about it. The only thing that really matters is that you can bring back the chain up so you can satisfy any attestations request. And mostly for the host OS, this should be completely transparent, like it doesn't care.
Yeah, and from Caliptra itself, we will allow hitless update of runtime firmware, but not the FMC. So that is really up to the SoC vendor, right? It's gonna be a choice of whoever is using Caliptra, right? And you can indicate to Caliptra that this component is updatable. And we're gonna actually track both the initial measurement, and then we will also collect the journey of updates, right? A PCR-like style extension. So you will be able to attest to both the current fresh measurement of the firmware module, as well as the whole journey from the cold boot through all the updates.
Yeah, extend
Correct.
measurements has been proposed as an extension to TP. Yeah.
Right. So it's not TPM, right? So we are not providing the logs like event logs in TPM world, right? Instead, you have the evidence inside the DICE certificate, right? And we are just keeping two type of measurements for the components that are updatable, right? As I said, one is the measurements of currently authenticated firmware running or software component, and the PCR style extended value, right? Yeah, so that's on the attester side, right? To track the updates, right? You have to track the journey on. Caliptra is not responsible for the updates, right? It's capturing the measurements for the updates, right? So whoever is tracking the updates and managing the updates can track some sort of logs and provide it to the remote attester, for example, if needed, right? But it's not Caliptra responsibility, because Caliptra is not root of trust for update, it's root of trust for measurements, right? Good questions. Okay, I think that's it.
That's it.
If there's any other question. All right, thanks.
Thank you.
Thanks, everyone.